Imagine a world without your phone, your laptop, even your car. A world powered by far less than we know today. That seemingly impossible scenario hinges on a tiny, unassuming square of silicon, the computer chip. But this inconspicuous piece of technology is at the heart of a global power struggle, a silent war fought over innovation, control, and the future itself. At its core, a semiconductor chip leverages the unique electrical properties of silicon. Silicon's ability to control electron flow, creating both conductive and non-conductive states, electrons and holes, allows for the creation of intricate circuits. These circuits, etched onto microscopic scales, form the basis of all modern electronics. Chips power everything from our smartphones and laptops to advanced medical equipment, self-driving cars, and industrial robots. Their pervasive influence is undeniable. The global chip industry contributes significantly to national GDPs and international trade, making it a cornerstone of the modern economy, driving innovation and economic growth on a worldwide scale. Chip manufacturing is a remarkably complex and expensive process. It begins with chip design, a meticulous process translating software into physical circuitry. This is followed by fabrication, where photolithography, using light to etch intricate patterns onto silicon wafers, is crucial. Subsequent steps involve etching, deposition, and ion implantation to build the chip's layers. Rigorous testing ensures functionality before packaging completes the process. This entire process demands incredibly advanced equipment and highly specialized cleanroom facilities, making the establishment of fabrication plants, fabs, a multi-billion-dollar undertaking. Moore's law, the observation that the number of transistors on a chip doubles approximately every 2 years, has driven relentless miniaturization and increased processing power, but it also fuels the ever-increasing cost and complexity of chip production. The global chip landscape is dominated by a few key players: the USA, China, Taiwan, and South Korea. Each nation's chip production capacity significantly impacts its national security and economic competitiveness. Taiwan, for example, holds a crucial position as a major manufacturer, creating a potential vulnerability in the global supply chain. Government policies play a pivotal role, with substantial subsidies and incentives shaping where fabs are built and influencing technological advancements. This competition highlights the strategic importance of chip manufacturing, prompting nations to invest heavily in research, development, and domestic production to reduce reliance on foreign suppliers and maintain technological leadership. The distribution of this critical technology is a key aspect of the ongoing geopolitical competition. Chip manufacturing's environmental footprint is significant, demanding vast amounts of water and energy and generating considerable waste. Research focuses on eco-friendly materials and processes, aiming for greater energy efficiency and reduced water consumption. Simultaneously, scientists explore alternative architectures, such as quantum computing, promising exponentially greater processing power with potentially lower energy needs. These innovations could revolutionize computing, offering solutions to current limitations and opening new avenues for technological advancement. The future of chip manufacturing hinges on overcoming several key challenges. Miniaturization, while continuing, will eventually hit physical limits, necessitating breakthroughs in materials science and chip architecture. We can expect to see a shift towards regionalization, with nations diversifying their supply chains to reduce dependence on single sources, particularly in response to geopolitical tensions. This diversification will create new opportunities for emerging economies. Furthermore, the industry's workforce will need to adapt, demanding a surge in skilled engineers and technicians proficient in advanced manufacturing and design. This necessitates robust education and training initiatives. The increasing complexity of chip production will also lead to ongoing innovation, exploring alternatives such as quantum computing to maintain the exponential growth in processing power. Computer chips are vital for global economic and national security, The race to dominate chip manufacturing raises significant geopolitical and ethical concerns. In your opinion, what strategies can ensure fair competition and prevent monopolies while fostering innovation in this crucial industry? Share your thoughts in the comments.